Oh, that's very loud. Okay. Well, thank you very much for coming. So today we'll be talking about a technology here, GPON technology. Yeah, that is based on fiber optic. Oops. Yeah. So I'm checking if my pen is working. Yeah, looks good. Okay. Yeah, so today we'll be talking about a topic here about providing internet service using GPON technology. So it's an alternative to perhaps the technology that you are using now. Okay, so agenda, we'll do some review. Talk about Fttx and then PON, and then if time permits, we can do some a little bit, you know, display about how the OLT is looks like. Okay, so introduction. We are GLC, Garda Lintas Cakrawala. We are based in Bandung. We are doing training in IT consulting for MikroTik Ubiquiti Linux. Yeah. And then we also have product for Radius Manager. And then also have a regular event like a webinar. So my name is Achmad Mardiansyah, and I'm based in Bandung, Linux user. I'm also a MikroTik user, other networking user like Cisco or also programming language user like Python or PHP, database user, Postgres. Yeah, so many users. Okay, so as long as all of them are good for um, giving a solution, then should be okay. So I have a LinkedIn account. I also write some articles in some websites. So if you have a LinkedIn account, and then we can connect. So that's the my LinkedIn account. So yeah, we can connect to that. Past experience, we do mostly networking, and then we also develop some software for our clients like billing and then network monitoring and so on and so forth. So we do like configuration from previous network, and then we upgrade to the new tech with the new technology. We convert from bridge network to the routed network, and so on and so forth. The webinar itself was started in 2010 for various topics, but mostly we are talking about networking, system administration, and what else? Programming. Yes, it's programming. Mostly around those three. So about yourself, if you don't mind, please say something in the group chat. Oh, sorry, I forgot to ask. So just want to make sure that is there anybody not from Indonesia here? Right. So yeah, otherwise I'll be speaking in Indonesia. If not, if there are people not from Indonesia, and then I'll be speaking in English. Okay, so I can see, I don't know where you're from. So usually there are people from Europe, Africa, or Asia. I can see, okay, let me scroll. There is somebody from, oh, okay, from Sofia, Bulgaria. Well, I guess I just have to keep going, speaking in English. Okay. Okay, thank you. Prerequisite, so we assume you already understand telecommunication networks, computer networks, and also network topologies. So in network topologies, we talk about how network is shaped, how the network is connected to each other, and then how it looks like. Okay, so we assume you already understand these three things. And then let's talk about the prerequisite knowledge that we assume you already understand. So here, when we talk about the telecommunication, we started from telecommunication, right? So we know that when we invent the microphone and then speaker, so we are able to communicate through a wire, okay, over a distance, a long distance. So we don't have to shout so that everyone can hear our own voice. Okay, so the thing is the voice can travel through cables using electrical signal. Okay, so that's the basic idea. And then because in the early days of communications, if we want to have a direct communication, then we have to lay cables on the destination from the source. Yeah, so it's going to be a mesh network like this. So, and then it's not efficient. So that's why we need to create a centralized place to put all the cables. Yeah, so that's why we invent the central office. So this is how the central office looks like. Okay, in the early days of communication. So all customers, so this is we call customer or the CPE. Okay, customer premise equipment. All of them will connect to the central office, and then inside the central office we have a human, human inside. So they are doing the functions for a call center. Okay, so that's why it's call center, and then all of them is called operator. So that's why nowadays when you see telecommunication companies, sometimes they are called operators, because I think in the early days in the central office, so we have a central office here, and then the CPE will connect to the central office. Okay. Yeah. Yeah, so they will pick your phone. So at in the beginning, there is no dial phone. Yeah, so there is no, I mean, dial pad. So as you can see, there is no dial numbers over there. So what you have to do is turn the key, make sure you doing it very fast, and the wheel, and then somebody will pick up your call from the central office, and then they will ask you to which telephone number that you want to call. So it's very funny today in these days, but a long time ago, it's not. Yeah. So that's how it works in telecommunication. So they are doing switching. Okay, they are doing routing, and then they are doing call center. Okay, so if you are really angry, they will they will pick up your phone. They will speak up to you. Okay. So the topology will be like what you see here. So from mesh, then becomes centralized. So it's going to be like a star topology, right? And then this, I think, also affects how the computer networks looks like. Okay, so usually you have, because the function of central office for switching. So that's why in the computer networks, in the middle, so there is a device called switch, right? That connects host. So host connect to switch, and then between central office or CO, okay, we can connect to the other central office. So the cable between the central office, sometimes at that time, it's called trunk. Okay, so that's why it's also, I think, brings an idea about VLAN. So VLAN is logical networks, and then the concept is same. So you have a switch, and then others also have a switch, and then the port that connects between the switches is called a trunk port. Okay, and then the port that connect to the end device is called access port. Okay, so that's how the network looks like in the early days. So we have layers in telecommunication. We have wires, okay, and then we have exchange. So every layer has its own functions. Yeah? So that's the concept of layers. Okay, so every layer has its own function. So we have devices layer to interact with the end user, And then we have a local loop, okay, that connects to a device. We have exchange, where the function is to route and then to do signaling. Okay, and then we have wires, yeah, to connect between devices. Okay, so if we see in the traditional communications, we have 3 layers: infrastructure, networks, and applications. Okay, and then on the network layers, it's separated. So we have a separate network for voice, separate network for data and video. Okay, and then infrastructure like a fixed network, telecommunication network. We have a dial-up, ISDN, 2G, 3G, and so on and so forth. So mostly these traditional networks can be seen in telecommunication company. So what about the service that they have? So unlike what we use right now, if we talk about telecommunication company, a traditional long time ago, their main income is from voice communication. Okay, but now voice is not that popular because it's much more expensive, and then there are much better way to do communication through with the voice. So that's why we have a data communication. So it means that it's packet network or the network that connects to the internet. So here we have the access network, and then the access network is upgraded. Okay, as the time goes by. Of course, if the operator has money to upgrade. So usually they upgrade from copper wire, normal two copper wires, and then they upgraded to ISDN. Some places they have ISDN, some are not. This happened a long time ago, okay, in 90s, okay. And then after that, they introduced ADSL as a cheaper option from ISDN. Okay, since 2000 in our country, in Indonesia. And then nowadays, since perhaps in the 2010s, they upgrade the access network to the network that is based on fiber optic, which is Fttx. Actually, this is Fttx. Okay, so that's how it works. Okay, the telecommunication. Then for about ISP, so ISP is actually interconnected networks. So they have their own networks, and then they are using a protocol, internet protocol, where it can unify all the applications. Yeah. So this is your ISP and you. Okay. So ISP is, if you see from the layer 3 point of view, so the backbone for internet is IP address. Okay, internet protocol, internet protocol address, IP address. So of course, every ISP, yeah. So you can see the net here. Net is ISP. So every ISP must have an allocation of IP address. Okay, they have a block of IP address which they will use it for their customer. So this is you, just one dot in your ISP. And then if after you log into your ISP through a series of authentication, and then you can connect to the internet, okay? And then you have to use internet protocol address, IP address, in order to reach other sites that is using IP address as well, like Google, Facebook, and so on and so forth. All right. So this is how it looks like, the topology, okay? So if in telecommunication you have a central office, so in ISP you have a bunch of a core network here. Core network. Okay, so inside the core network you have lots of routers, bunch of routers. So the purpose for routers is to forward packets. Okay, and then from the edge router or PE router. PE means provider edge router, and then you provide the access network to your customer, right? Through FTTH or fiber. You can use wireless LAN, you can use fiber optic, either fiber optic, Ethernet, GSM, whatever. Okay, so you have a core network, you have access network. Okay, so this is access network over here. Okay, so you have access network here, and then you have a customer. So customer will connect to your core network through access network. So what's going on here? Yeah, so this is you. Okay, so you connect to for example, a middle layer here, and then or the distribution, and then you connect to the core network. From the core network, you connect to the border router. Okay, so border router over here, and then the border router will connect to the other routers, and the journey keeps continue until we reach the destination. Okay. Right, so yeah, next is about the layers in internet communication. As I mentioned previously, yeah, the network here is using one single technology that is called Internet Protocol, or IP. And then this IP has addressing. And then with this addressing, we are using routing. Okay, so that we can forward packet from source to destination. So that's the main purpose of layer network layer, or in OC layer we we call it we put it in layer 3. Okay, on top we have a voice, email, whatever, and then DNS. So this is also important because internet protocol is based on numbers, and then we as a human, we don't like numbers. So that's why we invent the DNS as a technology to convert our like a domain name, so name-based addressing to an IP address, so which is very useful. So nowadays, if you have service, two things you have to keep. Make sure it's not down. First is IP address, and then the DNS. Okay, DNS is very important now. And then from the infrastructure point of view, you have lots of options. We have wireless, or this is also wireless. We have a cable, either based on a copper wire, a copper cable, or fiber optic cables. Okay, so if you have questions, and then please write something in the group chat, okay? So let's talk about Fttx, so fiber to the X. So X means what? X means it can be changed later on. So this is Fttx, so it's just a generic term for a broadband architecture that's using fiber optic as local loop. So local loop is a network from the core or central office, and then the customer premise. Okay, so over here is the central office, or your edge router, or PE provider edge, and then this is the usually the CPE. So between is called local loop. Okay. So if we use fiber optic as a local loop, and then it's called Fttx. Okay. So why we use the fiber? Because it can deliver more service. Yeah. Again, so most of the drivers for the new technology is the money, right? If we can sell more service, it means more money. Yeah. So for example, triple play. Yeah. If we keep doing it with copper, no, not really. Okay. So with triple play, we can sell voice service so that you can make a call. We can sell TV or broadcast service, right? And then you can sell, what else? What's triple play? Voice? Oh, data, internet service. Yeah, internet access. Okay. Also, it has a high capacity. Yeah, because fiber optic has higher capacity. Noise proof. Yes. Yeah. Sometimes it's the rain is raining heavily. If you are using copper wire, the signal is not that good. Okay. And then it can travel in long distance, so 20 kilometers, 10 kilometers, no problem for fiber optics. And then this is also good. The last one here is future proof. Okay, a normal single ordinary fiber optic cable can pump data up to 50 terabyte per second. But the current fiber optic now is just only 100 gigabit per second. So the problem is not in the fiber optic, but at the converter. So we convert from digital, from electrical to the fiber optic. So the fiber optic itself, it can send data up to 50 terabyte per second. But we haven't reached that at the moment because we have problem with the converter to convert from electrical to the fiber optic. In the future, who knows? Okay, so that's the theoretical maximum bandwidth that the fiber optic can deliver. So what you can do, yeah, you can just upgrade the endpoint, so the converter. Okay, so the fiber optic itself can lay down for years. I have project in 2010, in 2011, yeah, in a fiber optic to upgrade the network, and then the backbone of that network is already fiber optic. Okay, and then the same fiber optic was installed in 10 years ago in 2000. Remember, in 2000, they already have fiber optics installed. So with the same fiber optic, we can just change the endpoint, and then we don't have to remove the fiber optic cables and then laying down a new one. No, it's not like that. So with the same fiber optic, we can just change the endpoints, the converter, okay, the plug, and then from the 10 Mbps, now it can goes to 1 gigabit per second. so it's very long-term investment. About the variations, so it depends on how you implement the Fttx. So this is your central office. So this is the optical fiber, and then you combine it with the metal cables, copper wire. So if the fiber optic ends to this point, and then it's called FTTN, so fiber to node. So from central office to this one, I will use so from fiber optic to this one is fiber optic, and then from this to the customer, we are using what is it? We are using copper wire. Okay, so that is FTTN, fiber to node. C here is fiber to cabinet. Okay, so we have a cabinet here, and then from the cabinet we have copper wire to the customer, and then we have FTTB, okay, to the building. Okay, so from the building is fiber optic, but from the building to the rooms or to the apartment unit, we are still using copper wires like Ethernet cable or other technologies. And the last one here is fiber to home. So it means that from here directly to the customer is all for fiber optics, and then fiber optic up to this point, usually at the modem, and then after the modem is we are using copper wire cable. Okay, so FTTH now is one option that the provider are looking for. Okay, because it's end-to-end fiber optic connection. About the implementation, we can do AON, active optical network, or passive optical network. So what's the difference? Okay, we'll talk about that in the next slide. So this is AON. So this is how AON looks like. Okay, so this is your central office. Okay, this is your central office over here, and then here we have a node that is routing your packet. So from here to here is the packet, so it's layer 3. From here and then goes to the endpoint. Okay, So we have, because we have a router here, so it's going to be, and the router needs to have a power, okay, its own power. So that's why it's called active AON, active optical network. Okay. So and the good thing here is the data sent to the, for example, A to customer A. So the data from here to there, the data, the packets only sent to a particular subscriber. Okay, so it's not broadcast. So it's similar to like a switch. So this is like a switch. Okay, here is the switch. Okay, and then the switch is powered on. So after the switch, and then goes to the endpoint, to the ONT. Yeah, it's a single connection, like similar to a switch. So there is no broadcast here on the line. So that's why there is no collision. Okay, it's similar to Ethernet networks. Yeah, and then it's switching cable. So this is switching cabinets. Okay, can handle up to 1,000. Okay, 1,000. So the capacity is very high, or a typical is 500, 400. And then from there, here it can deliver a service up to 1 gigabit per second to the ONT here. Okay, so this is 1 gig. Okay, 1 gig, and then it's not splitted. Okay, so only dedicated 1 gig for ONT. Okay. Yeah, so that depends on the provider. If you if you don't have 1 gig upstream here, and then how can you deliver 1 gig to the customer? Okay, so this is the how the cabinet looks like. Okay, just example. Okay, so that was the AON. Yeah, because it requires active nodes in the middle, so that's why the cost of implementation is higher compared to PON. Yeah, so PON is similar to like a hub. Okay, so this is like a hub. Okay, hub means after you send a packet, and then the hub will send will replicate the frame. We're talking about layer 2, right? So layer 2 is frame. So the frame will be broadcast to everybody. So one line here, okay, so one line over here will be broadcast to this. Okay, so from downstream, okay, downstream packets is broadcast. Okay. What about the upstream? So from the customer, from the CPE to the OLT. Okay, so that depends. Okay. Yeah, so that means because it's broadcast. Okay. So that's why we need to have yeah, that can be a collision. Okay. So for downstream is broadcast, but from upstream traffic from A, customer A. So this is customer A, B, C, D. So A send to OLT, B sending to OLT. So when they send upstream, and then there will be a like a TDMA, so that they will not send packets at the same time. So they have a time slot for every ONT. So because the way it's implemented, it's like a passive optical network. So it's passive like a hub. So one splitter here, one connection. So this is a splitter, okay? So the splitter that splits the connection. It can only serve 128 customer, okay? Even less. So that depends. So it means that if you have 1 gig over here, you cannot give 1 gig per customer here. So that means with this passive optical network, so 1 gig has to be split it into several customers. So yeah, so you cannot give dedicated 1 gig to the customer. Yeah, because that 1 gig has to be split it. Okay, understand? Yeah, so yeah, there is a possibility to use encryption. And then we have a variation here like a GPON, EPON, and whatever. Okay, so that's the basic difference between active optical network and then passive optical network. Okay, so the GPON itself, okay, so one variation of PON is called GPON. Okay, so gigabit passive optical network, GPON. Yeah, it's a gigabit capable passive optical network. So actually the standard is done by ITU-T. So it's not like our standard where you can see from IETF RFC number. So here is the standard name and then from the ITU-T. So this is how you implement the fiber. So you have a OLT here and then at the end. So this is at the central office, okay? Central office. And then here's the home network, okay? Home network over here. And then here you have ONT, yeah, like your modem. And then from here, you can connect directly fiber optic cables directly to the ONT. Or sometimes people will call it ONU, okay? So here you have ONU, from here to ONU, okay? And then from the ONU through copper wire to with the network terminations, okay? Or you can use, if you have a cabinet, and then from fiber optic, and then we have ONU connect to others. Okay, so FTTB, so this is fiber to building, okay? Or fiber to cabinet, okay? Yeah, like what I explained previously, okay? So this is how we implement the GPON, yeah. So previously with GPON, as I said, we can deliver like a triple play. So this is how the architecture for the service, okay? So this is Ethernet service, okay? So this is the GPON medium. This is the standard. And then, yeah, so yeah, here it is, okay? So we are using Vlan. So here we combine, because Ethernet is not from ITU-T, yeah, Ethernet is from IETF. So we have IETF things here. It's like VLAN, so 802.1q, yeah, or 802.3. This is the Ethernet standard, right? And this is for, yeah, you can Google it for that, okay? So yeah, usually in order to connect to to the Ethernet, and then this is how it looks like. Okay, so you have a GPON PON medium, and then from one end to the other end, we can use Ethernet, direct Ethernet, or a VLAN. Okay, and then what about multicast? Yeah, so it is possible, yes. So here we are using Ethernet. Okay, so this is how we implement multicast. Yeah, so we have Ethernet over here. Okay, and then on top of that, we have a multicast. Okay, multicast service. Okay, so this is multicast is like you have cable TV, yeah, a broadcast service. Yeah, that one is part of usually triple play, right? But nowadays people prefer to watch YouTube other than that one. Okay, what about voice? Yeah, so as I said, triple play, right? Internet connections, TV broadcast, and then what else? The voice, yeah. So this is the voice. Okay, this is how voice looks like. Over here is the, I think this is the CP, customer premise side. Okay, over here. So yeah, when they connect, they will use SIP protocol to connect to the Oh no, it's not. Yeah, I think this is the other way around. Yeah, yeah. So they are using, they have codec. Codec is for service, voice service, and then they will connect through VoIP service. And then if VoIP service is using SIP protocol, session initiation protocol, we will have there is a plan to have SIP webinar in the future. Okay, so this is an example of deployment. So this is your router, okay, and then from this router you connect to the OLT, and from this OLT you have a splitter. Okay, so yeah, lots of them. And then from this splitter you put the cable to ONU. Okay, so as simple as that. And then from this ONU you have Wi-Fi over here, and or you can connect through cables, okay, to your PC. So this is how it looks like. For authentication, we are usually here we use a PPPoE, okay. And then from here, they're dialing the PPPoE service, okay. So we give them username and password, okay. Yeah. So as simple as that. So they can, when they connect, and then, they will, there is an authentication. And then after that, after they connect successfully, and then we can, they can access to the internet, okay, through IP address. If they have a phone here, okay, telephone, okay, and then there is a cable phone here, but on here there will be a IP address as well. So usually we are playing with the VLAN here. So for PPPoE, we are, for example, VLAN 100, and then for voice, we use VLAN 200. That's an example. Okay. So that is to distinguish the service. Okay, so that's example deployment. MikroTik also have a GPON, but only GPON modules like this one. Yeah, GPON module, and then so it's a discontinue, and this is how it looks like. Okay, you put it here. As long as your router has a GPON, it has a SFP plug, and then you put them in. Okay, so I think that's all. Any questions? Yeah, live practice. Any questions so far? No. Yeah, perhaps I can try to log into our test. Our test GPON over here. So what's the password? I forgot. Okay, let me check the password. Okay, so oh, here it is. Okay. So yeah, this is how GPON looks like. Okay. Yeah, so this is how GPON looks like, and GPON looks like this. Okay, this guy over here. Okay, this is GPON, and then on GPON, usually they have a management port. Okay, MGMT port, where MGMT port you can log into that. Okay, so it's similar to like a Cisco Cisco things. So here I already log into GPON, GPON OLT. Yeah, so this is how it looks like. Okay, easy. This is from the vendor. Okay, and then this is the chipset and so on and so forth. You can log in, and then yeah, perhaps we can try some help. Yeah, here it is. Okay, what else? Show, and then press here. Show device, show OLT, show OLT, for example. Oh, okay, the command is not complete. Okay, so OLT PON. This one, right? Okay. Yeah, I need to check the manual for this one. So OLT. Show OLT information, for example. Oops, not working. Yeah, sometimes it hangs. Yeah, see, after I press enter, nothing happened here. Okay, so this is how you configure the ONU. I mean OLT. So I'm logging into OLT in our test data center test site. Okay, so we are playing around here. Okay, sorry. Looks like it hangs. Oh, Control C, not working. Yeah. Okay. Oh, okay. Here it is. Yeah. So this is an example. Okay. Show whatever. Show VLAN mode, for example. Okay. So VLAN mode is 1 queue. Okay. And then if you want to modify something, you have to do enabled. That's similar like a Cisco, right? And the password is secret. Over here. Okay, so here you can config, yeah, config. Yeah, so it's up to you how you want to config your router. Yeah. Okay, so can you tell us about Odp Enclosure? Well, Odp is the optical data. So wait a moment. Yeah. So it's similar to like copper wire, right? So in the early days of telecommunication. So yeah, here. So here in telecommunication, so this is your CPE, and then inside here is the distribution point. So from central office, they are laying down a big cable, and then inside the big cable there are lots of smaller cable, and then each small cable goes to the CPE. Okay, so here they put the big cable over here to the, we call it DP, distribution point, and then from this distribution point, they allocate a cable from from that point, from that small twisted pair cable to the to a CPE. So from here to here to here. Okay. So same thing with the GPON. So there will be, because GPON we have a distribution point. Okay. Yeah, so this is the distribution point. So yeah, so once you connect, and then other will be split it, okay, into more customer. Okay, so coming in one cable, and then the cable will be split into several split it into several connections. Okay, and then here's the output, for example. Okay, so yeah, that's how it looks like. And then which one is better, GPON or EPON? Well, GPON is gigabit passive optical network, and then EPON is Ethernet. So which one is better? Well, all of them are okay as long as we can use it, as long as it's cheaper. Okay. So yeah, that so in terms of good or not, that depends not only the technical. I think technical is same. Yeah, so this is just a layer 2 technology, can be replaced in the future. Okay. Yeah, so yeah, for me, GPON, EPON, well, yeah, it's not depends on the technical, but also for a business point of view. Okay. Okay, so that's how it looks like. Yeah. So EPON is, I'm not sure. I haven't checked the specification for EPON. Okay. Yeah, for GPON, as you can see, it's defined clearly from ITUT for, yeah, here. Okay. Oh, I need to clear up the drawing. Yeah. So for EPON is here, for I mean GPON is here, but for EPON, yeah, I haven't checked the standards. Can you show the traffic profile? So here we don't have traffic profile. So so what we use here is just a dumb OLT. I haven't checked the manual, so yeah, I'm not expert in OLT, and then I don't want to be expert on this OLT, because there are lots of OLT, lots of them. So I would prefer myself to have a more experience in other areas rather than just OLT. Okay, every OLT has their own stuff, and you have lots of brands for GPON. Yeah, there are lots of OLT that is capable for handling lots of traffic. Okay. Right. So yeah, anything else? No. Okay. So this is how it looks like. Okay. Show what is it? Show Vlan, for example. Yeah. Show Vlan. So this is the Vlan. Okay. So, and then here's the port at the ONU. Okay. Vlan 53, so on and so forth. We can do like, so this looks like a Cisco, yeah, but it's not Cisco. Yeah, you can use a question mark for what is it? For help. Okay. Oh yeah, one more thing here is the common questions. Okay. Okay, let me share the screen back. So here, as I said, in our OLT, test OLT, here we don't have any traffic profile because all the customers are in PPPoE. So we we provision PPPoE. Okay, and then we put the profile over there. It's like, so this is your maximum, what is it? Your maximum speed. So the speed control is controlled by the MikroTik. Okay. Yeah. Yeah, so here's the question. So we have OLT over here. We have ONU over here. So this is brand A and this is brand B. Is it possible? Yes. Yeah, but sometimes and often, sometimes in, for example, in Indonesia, so if OLT is A, ONU has to be from brand A. Yeah, so it has to be from brand A. And then it has to be registered here. Registered at the OLT here. So you cannot just buy ONU and then just connect. So usually they have a registration ONU over here. Okay, so they are very strict with with the ONU. So only certain ONU can connect to the network. Yeah. Right. So any other questions? So hopefully, yeah, by finishing this webinar, you have an idea about how the GPON looks like. Okay, right? And yeah, as a last slide, I think yeah, there is a message from admin to all of you. Okay, so I put it here. So this is end of the slides. Okay, so thank you very much for your attention. Please submit your feedback over here. Link is available in a group chat. Further events will be available in our website, so you can check. You just go to our website and then click the schedule. Yeah, Facebook is also available. We post schedule on Facebook for reminder. Slides will be available on Slideshare. We have a Discord also here. Yeah, in Bahasa Indonesia, unfortunately. So if you are Indonesian, then please join. Recording will be available on YouTube. Okay, so I think that's all for now. I will stop the screen share, and then it's time for a photo session. Okay. Right. So please turn on your photo session. Turn on your camera. Sorry, turn on your photo. Sorry. Yeah. Better display all of them. Start video. Okay. Turn it on. Okay. Yeah. So guys, I will take a picture. So please thumbs up. Yeah, we'll count 1, 2, 3. Okay. Okay. One more. 1, 2, and 3. Yes. Good. Okay, guys. Again, thank you very much for your attention. Thanks for coming. Yeah, so hopefully you get a benefit from this webinar, right? Okay, so again, have a nice day. Keep safe, and then see you in the next webinar. Okay, thank you very much, and goodbye. Oh, okay, I have a chat here. What is it? Oh, thank you, Ahmad. Another great course. Yeah, thank you. You are welcome. Thanks for coming.